morning. Holy fuck. A lot of people here speak English. Well, that was a surprise. When I got moved downstairs to the H2HC University, I thought that nobody in this room would understand a word that I said. Now I'm a little more nervous. So this talk is not about virtualization. It's about visualization. I just wanted to add that caveat, because if you want, you can go and see Jason Street's non-technical talk upstairs, and but you can stay down here with me. And we're going to talk about visualization. I work at the University of Illinois. I'm a researcher there, and we make tools that visualize network flows and attack surface. Am I too loud for you? What does this mean? No, I'm not too loud. I can get louder if necessary. You want me to get louder? Okay, I need to be louder, I'm sorry. So, this is where I live. It's flat, and all the corn is gone because we've harvested it already. But, I flew into São Paulo a couple of days ago, and then, like, in true Brazilian fashion, I got a message from Rodrigo, one of the conference organizers here. Anybody know Rodrigo? Yeah, a few people maybe. So my phone finally connects to the Brazilian network, and I see like, oh, Brian will be coming to meet you at the airport. And I was like, oh man, how am I supposed to meet somebody at the airport? But everything worked out because I kind of like, he was there waiting for me. So we got in the same car together. And the one thing that amazes me about Brazil is that this last minute planning that's done and everything just kind of comes together and everything's fine. But I was very tired because it's a long flight from the United States to get here. And but they let me check into my room early, so I had a nice view from the room. And then I was hoping to get a nap because, in the true tradition of Brazilian conferences, they like to take you out to a party the night before you're supposed to speak. And so I'm starting to relax in bed, and I'm like, I have plenty of time, and start hear drumming noises. And then I look out my window, and I see there's an entire, is this like something that you do in your culture where people get together and beat drums in the courtyard underneath a hotel in the middle of the afternoon when people are trying to sleep? And I had no idea how to complain about this because it looked like an official event. So it was pretty nice. I don't know if anybody was here for it the other day, because getting into the conference, I had a very long week, because like I said, I'm a researcher at the University of Illinois, and what we do is a lot of things. We build tools that visualize network flows and critical infrastructure, and we also have critical infrastructure in our lab. And we just got finished a big exercise, and what I did was, I have a lot of pictures of different places that I've been on the power grid. And I never thought that I'd be able to add pictures from a series I like to call stupid shit that I've seen as I've been working on critical infrastructure. So we had a project where we had to build little substations that we were going to deploy in this mobile experiment. And there was like 22 substations. And like we were at least 2 weeks behind. And the cabling and everything and the protective relays and stuff that we were doing was a feat there. But the thing that's interesting is, even if you don't understand English, what you're getting ready to see might be a little fucked up, because I went off and we did the cable management for the switch. That's a Schweitzer, it's a switch that sits on the inside of the substation and does all of the control signaling. And if you look, I come back and our electrical engineers have taken the switch out and they're just letting it dangle down outside of these boxes. And I'm like, ooh, that's not good. What? And again, this is a visualization talk. All I'm trying to do is visualize how fucked up my life is sometimes. And I think that maybe you're getting a picture of that. But if you really want to look at this a little closer, it's like, what human being thinks this is good outside of Brazil? Come on, we're going to fight about Brazil. Would you like a drink? But look at this. So the entire weight of the switch is being held up by the power coupler, which was actually like wired into that thing. So there's 120 volts of AC going through that wire because they didn't bother even turning the switch off or de-energizing. It's just kind of like laying there. It's just like a disaster waiting to happen. So this is what I had to deal with before I could come to Brazil. So I did drink heavily after I got here. And then these are some more switches that we were working on in the lab. But the lab just looked like a bomb went off in it. This is like the state that we were in because we had so many things that we needed to put together to get this thing done on time. And then at the end of the day, things were kind of coming together. But when you're trying to put the thing together at the end, and the electrical engineer does all the internal wiring, because, you know, network guys aren't allowed to touch the electrical engineering pieces, because here is a mass of wires that have 120 volt AC, 48 volt DC, 9 volt DC, 6 volt DC, and telemetry all in there, and they're all the same colored cables. So now we got to rack these things up, because these things have 48 volt DC in them, and if you know anything about 48 volt DC, is that that wire comes loose and it connects to you, it won't let go. It will kill you. So this one's on too, I think, by the way. So I'm like, oh, this is pretty dangerous. How am I supposed to get this into a DIN rail? I have to turn this 90 degrees to get it into the DIN rail, so we had to have them rewire the entire thing, because it's supposed to look like this. So those things are supposed to be faced around. Nice and neat, right? So you get the idea of this visualization where I say, this is bad, and this is good. So can we all get past that? Is that like, am I communicating effectively so far? And this is even better, because this means that I can leave and go to Brazil. So this idea about privacy, though, is like, we're going to have a conversation, and I may say a few things that are contrary to the place where I work, because I really don't necessarily represent the official opinion of the university I work for. This is my opinion, and if you know me, you know that I'm not very shy about letting you know what my opinion is. And, hey man, can you close that door when you come on in? Thank you. I don't feel like I don't want to get very loud, because the actual talk is starting in a minute here. So now that I'm warmed up, I want to talk about visualization because, you know, I found a visualization of, anybody ever heard of JavaScript? You know, that runs in web pages and stuff like that. So this is a visualization of JavaScript. Does anybody see a problem with this visualization? It's a very detailed visualization, and I don't know, I can't glean much out of this. It looks about as good as the picture of my substation earlier. I don't know, I can't get anything out of this. And then a lot of problems with visualizations are if you put too much information in it, you can make it do or say anything that you really want. It's like, you know, oh yeah, I can find the bottom. You know, this is it. Everything's going to start to come up now. We've got all this information in our visuals, and then visualization is also a function of perspective. So I don't know if it's made it down to Brazil, but do you know what color this dress is? So when you make a visualization, you don't know what the person that you're giving that visualization to is going to perceive, because they may see this dress as a different color. Because I don't know the words for, what's this color? We're going to get an argument here because I think people see this in two different colors. But at H2HC, we like to, you know, pull underneath the hood, so to speak. But I think that we're not going to get involved in that kind of visualization because, you know, as Bert says, Ernie educates Bert about why the Japanese deserve a third nuclear bombing. So we're not going to get involved in that type of visualization. This is actually going to be proper visualization. So in my country, we have a Department of Defense that's very good at providing visualization about everything. So this is the Integrated Defense Acquisition Technology and Logistics Lifecycle Management System. So, of course, everybody here can completely understand how we do things in my government by looking at this visualization, can't you? It's very straightforward. All the information that you need is there. But, you know, again, it doesn't look much better than that substation picture I showed you earlier. But you can also do a lot of powerful things with visualization, such as, you know, if I'm looking for pickups inside of a chip and I have access to an X-ray machine, maybe I can figure out where I need to use my microprobing station to get certain information out of computers. And it looks really cool on a slide, right? But a lot of people are into network visualization. And so this is a tool that I run on my computer. It's called Glasswire. I don't know, has anybody else used Glasswire? Good. So you're going to see this Glasswire. So what it does is it just measures all of the network traffic on my computer and also looks at all of the executables on my computer and tells me when they change. So I can get notifications when things are updated or changed, or I get new network flows, and then I can make decisions about what I want to do with this new network traffic. But it took a while to set the video up because I'm going to do demos. So what we're going to do here is tempt the God of the demos and see how the first one's going to work out. So hopefully the screen will come back on. All right, so the AV guy and I are still in Congress here. Now let me find this tool, because I've got a few things running on my computer right now. No. I don't want a VPN into work. I had this all set up and organized before Balestra made me move my laptop. Here we go. So this is Glasswire. So what I can do is I can look at, like, I think I'm still connected. This is like the last 5 minutes of traffic that I've seen while I was doing the presentation. But what I can do is I can also look at 3 hours, and the visualization is going to move and give me more information. But you see, like, when I was home downloading some stuff to get off my computer before I left the country, because I get concerned about borders, just like anybody would. Oh, wait, this is 3 hours. Let's find the good one. A week ago. There we go. So I was pretty busy. But then you can do things like you can see, I can see where all of the applications inside my computer are going to. And the reason I mention this is because this is a much better visualization as far as I'm concerned, because I'm a system analyst at heart. And now, I'm going to all these different places, and then I get a use of what my bandwidth is, and then I can also do interesting things, like I can block access to applications that want to go out on the internet. Like I block my screenshot program, I block a lot of different programs I really don't want to just communicate indiscriminately to the internet. That's not really a good idea. So, but the idea that I wanted to really portray about visualization here is that the more fine-grained you get a visualization, you can see what's happening now, but if I want to back up and look at like all of the data that I've captured, and this is like almost 2 years of data, but I get so much density in the visualization, I really can't get anything specifically about what might be happening right now. I can just see weird trends, like there are times when I download or upload a bunch of shit off my laptop because I'm always moving stuff around. And I lose a lot of the detail by looking at a high level. And then we're going to possibly see this in some other demos. But so this is Glasswire. I didn't write it or anything. It's just a program that I use. And now I need to figure out. So like I said, this is like the power grid in the United States. It's really big. It goes for thousands and thousands of kilometers. But again, here's another dense piece of visualization that it just looks like a bunch of lines on a map somewhere, because, you know, it does look like America, I think, but, you know, you guys, we're in Brazil, so it represents, it's a map of America. This is like the lab where we have some power grid equipment at work, and so we're doing a project, and so this is kind of like what real power grid equipment looks like. That we have an application running on that laptop. But we're at a hacker conference. Does anybody see anything else interesting in the picture? Maybe some, I know that this DEF CON dog has an idea that there might be something interesting in this picture. And that's we have the username and password for the devices on the chalkboard by the devices. So the whole idea behind what we're doing with the research on this particular device is we want to give the adversary the credentials for the application because we're looking at technology called SGX. Now, there's some people here who know a lot more about SGX than I do. I'm not really going to talk about SGX at the presentation, but I'm going to make a visualization to show you what SGX can do. So this basic application that we have is we have a relay, which is a piece of power grid equipment. We collect information in the field, and it goes to a SCADA network, which that's where they operate the power grid. So we built a little box called Badger 3.0, and then we put this SGX on top of that. And what SGX is going to do, it's going to encrypt critical information like any kind of settings or passwords that we need and protect it from access from the operating system. So the idea is if you go in and then kind of connect this data into a flow application, you can provide a completely encrypted enclave of information from an operational device all the way into things where they would operate in a corporate environment. And so the idea, as far as visualization goes, is so with a very simple diagram, I can try to express something that's quite complicated to you so you can get at least a high-level feeling for what is actually going on in this data flow. And there's not a demo of this yet because it's something that we're working on right now. And then I work with a lot of PhD and postdocs, and then we also get a lot of benefit out of simpler diagrams like this one, where this is I guess, for lack of a better word, it's a rootkit that one of the students wrote. We wanted to build a shim between the kernel and user land so that we could stop certain processes from reaching the net filter. So we built hooks around the net filter. And this is kind of like our first representation of what it is we want to do. Whenever you're trying to convey something that's technical, you want to get very simple with your diagrams. Because, you know, I can make it or show you a diagram that we did. This is our lab. And then again, we have a lot of information on the screen, but it's very hard to ascertain what's going on. So if we just look at a particular piece of this diagram and say, okay, here we go. This is a power flow. So we're in this application, and we see that some bad guys are getting in, and maybe they're hacking into stuff. And then we have some stuff that on the power grid operational side, things are turning red. So you can get an idea. Things might be going on. So what's happening under the hood behind here so that we try to map physical connections and impact together. So like what would happen if A got hacked? What would be the impact on the larger system? In order to do that, we have to look at all the individual components of the system, and then we can graph what it looks like normally. So this is normal power flow state. And then when something weird happens on the power grid, there's a perturbation, and the power starts to come back down to steady state and get flat. Now, again, in terms of visualization, I don't think any of us need to be an electrical engineer to know this is not a steady state. There's a problem here. Can everybody see that? There's a problem. It's pretty clear in the visualization that there's a problem. We don't know a lot of reasons about why it is. I just know that's bad, and I'm not an electrical engineer. And in terms of modeling, we do a lot of things like, oh, here's a bunch of different substations, and then we wrote a tool that did visualization of 8 substations based on the IEEE model. And so here's a screenshot from the tool. And then we played with different visualizations, like we had a tree that we tried to use to show individual components inside a substation yard. But the problem we had was like when it got to show 300 substations, there was a problem because it got really dense, and then everything really didn't move around well inside the computer. So we tried D3. So this is kind of like a screenshot of D3 and what it looks like when, and it looks really shitty on this screen because, I don't know, this is Brazil, and maybe my computer doesn't like Brazilian video adapters. So here's another picture of substation networks, but I think that it's better just to show you the tool because it's a tool we actually wrote. So let's see if this works. Okay, here we go. So this is the tool that I had the screenshots of. Let's see if it's still working. So basically what it is you have a blended view here where we have a list of all of the different individual components, and then I can look at the cyber security view. We also have a view of the physical network. So here's the physical network, and then what we can also get is if we come down here, I can get a list of which hosts are patched and not patched. We can mark hosts as being compromised, and then you can get a recalculation of the top N priority devices, and then back to the visualizations. So this is I'm going to zoom out a little bit so you can see both of them at the same time. The same visualization that I had the screenshot of. So if I zoom in here, we can see the Springfield sub, and then we have Ogdenville, Harris, and Cypress Creek. And then there's Haverbrook and Capital City, North Haverbrook. So pick a substation. Which one do you want to see? This one's good, you sure? All right, let's see what happens. I'm going to click on it. And so when I click on Shelbyville, I'm going to zoom out a little bit. Hopefully you can see this. I see that I can get a overview of the network over here. And then, so this is a tree view, so I can click on this, and then I get a view of what's in the yard. So the idea being, how do you de-nest these things and get a better visualization about what's going on in something that's a little complicated and spread out? But again, even this tiny screen, it starts to get busy, and then I can click on individual links and get information about specific devices in a column that really doesn't come up when I'm in 1024 by 768 or whatever small amount of real estate I get to project on right now. But the other visualization we worked on is kind of like this. It's a tabular format where you get all of the information sitting on the left side, and it's kind of faded out here, but we still have the capital city, Cypress Creek, Haverbrook, etc. And we just looked at Springfield, so I'm going to click on Shelbyville, which is right here. It's the link right before it, and see that each one of these substations is now represented in the right screen. And you can get a better idea of where each location is and what devices and where the connectivity is in here. And this is a live diagram that also has an entire markup language behind it in OWL. And you can do different style nodes. And if you're into that kind of JSON-y thing, you can make and add a lot of rich metadata into these documents with this. And this is open source. You can actually download this. I can give you a link to it or something like that, but I'm not really trying to hawk software that I've written. I was just showing you the visualization because, so if we go into this is the 300 substations, and if I were to try and zoom into this, it would take approximately 30 seconds to go in 1 degree. So it would take a really long time to get it, seeing one substation. This is like the problem that you have in visualization, and then like I said, we tried D3 for a little bit, so that this exact diagram over here, where we have all these different substations, we did it in D3, and it kind of looks like this. So now, here we have 8 substations, and it's visualized in D3. So, I can zoom in on this and grab something and move it around, but then I have no idea where I am with this little one device, and then I have to zoom back out, and then I'm losing it again. And so from the perspective of we build tools, are we wasting our energy and resources in making visualizations and tools that effectively don't really provide anything but really cool demos that you can do at hacker conferences? So we're not done yet, but that was a demo. Let's see if we can get back into the slides. There's another tool that I worked on called network perception. So what it does is it takes a firewall and ingests the configuration of firewall and makes a diagram of the attack surface. And you can make pretty pictures like this. This is like what a power grid would look like a real utility that operates a power grid, and what they use for things like EMS-specific traffic, and you can make really nice visualizations, but it all comes out from things like, oh, I can also show specific protocol traffic in this visualization. And then as academics, we get funding to add on features. So there was a government agency that asked us to add this idea of how do you measure attack surface from what can get to A from B, and then what can get to B from C. And how do you really visualize this idea of attack surface where, if we look over there on the left, or if I zoom in a little bit, you can see you get some numerical information about how big the attack surface of different things might be. So I can see that while there's only one device that can directly connect to this, I see that there's 78 devices that can connect to this device to get to the other device. And then we could try to measure these things in attack surface mathematically, because if I do 10,000 things on the screen, you're not really going to be able to see it as a human being, but we can see it mathematically. And then like the tool, you know, it kind of looks like this when networks first come out, and then this is kind of like what it looks like if you expand everything initially. But, you know, I was drinking last night. I'm kind of like drinking already today. I'm doing a lot of demos. So we're going to try and do another demo of this actual tool if I don't really just blow out the presentation here. Let's find this. So I've already loaded the firewalls into this tool. So this is actual firewall information. So if I go into the map, I can kind of like expand all the nodes, and you can see that this is also a live tool where I can go in and see that this is a network of, I think this is a control network somewhere. And then, again, with the idea being a recurrent theme in this talk is when I zoom in to get more information specifically about an object, I lose a perspective of where it is in the larger diagram. And then how do I present that when I'm in front of a bunch of people trying to explain how complicated the power grid might be, and they say, oh, this is the inside of the power grid. But then I have to zoom back out again and go, and if it will let me zoom out, there we go. And it's connected to all this other stuff, but now you're really losing focus on what was important because we have a much larger diagram, and you're losing the frame of reference about how that one specific thing is connected. And this is a very hard problem in visualization, because do you want information that's relevant to you as a security analyst, or do you want information that a non-technical person is going to understand that this is complicated? And then, so that's like the story behind this tool. And, you know, if I'm still sober later, you can always come to me and I can give you a more detailed view of any of these tools if you might be interested in them. But I don't want to be here all day, because I'm not going to be the single man at the H2HC University today, unfortunately, or fortunately, because you're probably already sick of me anyway. Let's see. So let's see if we can get back into this, because, you know, at my heart, I am a security analyst. Oh, and we have another. So this one's an interesting one. So the tool I just showed you with the 8 substations is going through a new version. This is like a mock-up of the front end. And so we'll go right back into another demo. This is the actual tool. So the problem is that I can't really give you a good visualization because it's got some problems with missing paths, and then possibly the researcher that wrote this tool did it in, anybody ever heard of Pascal? Right? Pascal's not a person, it's a language. So do you know that there's actually a visual Pascal? So this is written in Visual Pascal. It is a complete nightmare of an application right now. So it's being completely rewritten in HTML5. So, but right now it's loaded with all kind of vulnerabilities. But the owner of the software was notified because I'm the owner of the software. So there was responsible disclosure in this problem, but this thing is riddled with problems. And Pascal is bad. It is very unsafe, and it really shouldn't even be mentioned, ever. But there are power grid applications that run on a development suite that is basically Visual Pascal. So The third world still exists in America in terms of running software in utilities. So, all right, that was a quick demo. So now we got to get it back on the slides because, let's see. All right, so I'm also working with another group of folks where we're trying to visualize the NISTR logical reference model. So the government gave us a bunch of money to categorize a bunch of regulations that are called the 61850, which is a standard for the power grid. You don't really need to know anything more than it's very convoluted. This is kind of like a 2D graph of all the relationships between objects in the NISTR 61850. And you can kind of zoom in a little bit on this and see some of the things. So we were playing around with a certain library, and we have a tool that kind of like does a turn on visualization here. And of course, we're going to do another demo because I haven't done enough demos yet in my talk. So let's see about this. Is it actually going to work? The screen comes up. So here we go. This is the NISTR model, kind of like you saw in the screenshot, and we can zoom out a little bit. And then you can see I can turn the visualization on its side, and I can get a frame of reference for different pieces of operation. And doesn't that look cool? It's really sexy. And I got a lot of information here, but then I can go over here, and I'm going to try and drive this from here and not from the screen because I really think I need a third set of glasses to see anything that's on this screen. So if anybody wants to see this later, I'll leave it running in the laptop if you can find me before I get too drunk. But I can go, and over here on the right we have these different categories. So I can click and get a filtered view of different pieces of the operation that we might be interested in, and feed, and in the next version of this visualization, we want to feed real-time data from both cyber and physical impact into a diagram like this so that maybe it can pulse and you can remove certain aspects like the business-to-business connectivity or see where it might be inside this visualization. So I think this might be the first time I've showed this one on it in a different hemisphere. So does it play well in South America? I mean, did this suck? I mean, what do you think of a visualization like this? Awesome? Now, I think that the word, if it works, because I understand the word terrific means something different in Portuguese. It's like, it's shit, right? I think this is terrific. Because, you know, in my language, terrific is a good thing, but I think that what you really don't get is like, I still have basically a really pretty diagram I can zoom into, but there's a lot of complexity involved in sending information into a diagram like this in real time. But I can do cool things, especially in a demo with non-technical people to show that, well, you know, here is the systems that are connected to AMI, and then I can kind of like maybe just remove everything from the diagram and show only those systems so that you can see the AMI piece of this is just a very small layer inside this nested object. And you can see in this entire piece of operational equipment, there only are a very small number of things that actually do anything. And then if we click back on this, there's supposed to be a button that I can click on and it turns everything back on, but in the true spirit of hangover and not quite drunk yet, I can't find that button. But there are also filters that you can come in here and then add a filter if you want to select different things and search on metadata and individual devices. So yeah, it's, what was the word that somebody used? Awesome. That probably goes well between both of our languages. I think it's terrific. Let's just leave it at that. This is possibly available via open source if I remembered to turn it on in the GitHub. It's actually in the GitHub. You can download it. It's JSON. So you could run this in a browser just like I am. This is the one thing that we need to do is, though, the grad student that wrote it dropped some of the JSON config files online. So you actually need to be online to load the tool. So like, the first time you do this in a demo, you have to remember that, oh, I need to load the demo before I do the presentation. I'm giving you like my inside secrets here. So like, I don't need to be online, but if I wanted to change the size of the diagram, I need to be online. And one of the things we're trying to work on is to make the application portable so that you don't need to be online to change the screen size. So, airing all of my dirty laundry in front of my friends in Brazil and whoever might be hearing me in the video. Here we go. So let's get back and see what's next, because I think I've got a couple of more demos before we're done, unless you just want me to end now, because I think I'm ending on a pretty good note if I stop now. But I want to talk about this, because this is awesome to me. I'm a security analyst. I like to see flows, and off to the left, the IP address column is hidden because this is real data. So we work with a utility, and what we're doing is modeling their primary protocol that they use to communicate with substations. And we made a few visualizations, and you know, the idea behind power grid traffic is that it's deterministic, and then that there is predictability in data flows. And if you look at this visualization, it really depicts that well, doesn't it? Does that look? It's very predictable what the data flows are going to be, but the interesting thing is if you zoom in, you don't really see that same thing, and we're going back to the same recurring theme where when you provide more detailed information in a visualization, you lose the bigger picture. But I'm getting tired of this presentation, just like you are, and I'd rather just see another demo. So should we actually load up the live demo here, the live data in a Wireshark, and we could take a look at it. So let's see. The actual graph is right here. So this is actually from a different trace from the screenshot. This is our DNP trace number 4. So you have here these little bumps where you see a burst out of traffic. But again, if I zoom in on the diagram, you can see that there's a layer of abstraction here when we zoom in, but then we're losing the bigger picture. So in terms of visualization, how do you really depict that there is this jump up and down in packet rate in this diagram that you really can't see when you zoom back out again? And this is traffic over a 14-hour period, so it actually took almost 2 minutes to load the graphic in Wireshark. And it's kind of a miracle my laptop hasn't crashed yet with all these programs that I'm running while I'm doing a presentation live. But I think, let's see if I did this correctly. I did. Nice. So here's that same column with the IP addresses redacted off to the left. So if I wanted to be really cool, I could kind of move over here and tease you and show you the last octet of the traffic. But so this is like communication out to substations, and it's control traffic that keeps the power up and down. And one of the things we noticed in this run of traffic was that there were a couple that were like not working, and so they had connections in place, but they weren't actually using this protocol in production yet. So you know, I could see that as an analyst that 0 is not good when I'm supposed to have a deterministic traffic flow. But if I go back to the visualization, I can't really see any zeros in this. I mean, it looks like a very deterministic traffic flow to me if I zoom out on it. Pretty steady rate of packets. So let me see if I can find my presentation again. So this traffic that I just showed you in Wireshark also looks like this. So I actually don't have access to this application to show you live, short of hacking into a Fortune 500 utility live while I'm on stage in Brazil. And the network here is a little bit hostile right now, so I don't think I'll really want to do that. But if you were to go into the NOC, they have a big giant 4K screen, and this is all of the flow of traffic at this utility. And they did a lot of work to block out all the names of the substations to release this so that I could show publicly the flow diagram. But the thing that's more interesting to me in terms of visualization is it's a really cool visualization. It's awesome, right? Isn't this awesome? It's also terrible because look over here. It's terrible. It's not terrible. What was the word I was using earlier? It's terrific, exactly. Because if you look over here to the left, you see all those blue squares? That's 400 devices that can't fit onto the screen because there's not enough computing power in the server class machine that is doing this, basically pulling this information off a tap and visualizing it. This is the state of the art in real-time visualization. And this is a very small network. It's 400 devices. And they can't provide anything more than what you see on the right, and they have to dismiss traffic from 400 different flows. And then, like, if you zoom in further, we lose a complete picture of the context of the diagram again, but I get more fine-grained information about how the different EMS servers communicate to each other, and then what specific TCP protocols they're using, and then I can relatively size the data flows by using little circles, and it looks really cool. But again, if we come back out again, I really lose that detail in the visualization. So the real question is, as developers of tools, is visualization necessary still? You know, that's the real question. And that is the end of the presentation, I think. So I made it all the way through all of these demos without anything going wrong, other than I've probably started some kind of really big feud between me and the AV guy in the beginning of the presentation because he wouldn't listen to me. So if anybody has any questions, we can maybe take some now. I don't know. This is a Brazilian conference, so I don't know that they're really paying close attention to when the talk is going to end and how much time I actually used. Because it's 10 o'clock, 10:09. So, any questions? Anybody?
Eu acho que você conhece Dark Trace. Dark Trace.
Dark Trace.
Yeah. No?
The movie Hackers.
No. Dark
No.
Trace, a tool.
Dark Trace is a tool. No, I don't know that tool.
Okay. Because the visualization reminded me a lot, and the details, the style.
Yeah.
I think
the style is common because what we use are open source available libraries for visualization. You know, there's D3 in these visualizations, and we use JSON and tools that folks like the people who wrote Darktrace would. So a lot of these tools are going to look similar.
Yeah.
And what differentiates the tools is the data that you put into them to make the visualization go. And as an analyst, you need to understand the information that's going into the visualization, because folks that don't understand your field of expertise are just going to depend on the visualization to get an idea about what it is you're doing. So yeah, it's a great question though.
Hi.
When you have a cloud infrastructure, you don't have border devices and some device that have this information. How you resolve to monitoring those connections and those devices, what lives in your network, and you are not monitoring that, like AWS or?
So I think you're asking the question about how do you ensure that you're seeing all of the network traffic, and how do you use taps or traces to get the data? Like if you look at how does the data come from this visualization is maybe as an example of the question that you're having. So this utility has a tap on the backbone. So they tap the entire Ethernet switch in a 10 gig connection, and then it gets put into a 48 processor computer. So there's a lot of hardware behind a visualization like this, and it's not like a bump in the wire like you would see with an Ethernet tap or something like that. This is done at the switch level. And I don't know if that answered the question you had, but I gave it a good shot.
Okay.
And you can see me after. I'll be around all day. All right. Well, thank you very much. Hopefully the talk wasn't terrific. Good morning.